Then we have 4 minus 3 times 1 squared plus 4 minus 3 times 2 squared plus 4 minus 3 times 3 squared plus 4 minus 3 times 4 squared. So we stop. Why did I stop here? Because the end point is 4. So this is 4. This is 3. That's 2. That's 1. That's 0. Because the I only changes. Correct? That's the first step. We just list them. Now we need to add them up. We have a parenthesis. So you take care of this. So we have a parenthesis. So I don't hear you very well. Who are you? Syria. Is that you, Syria? Somebody said we have parenthesis. Continue.
I think she just have her audio open.
Sorry, I was trying to record this.
Wow, good. Very good. That's
My
fine.
fault.
So recording things, you're gonna have exactly same question. No, similar in exam. But
Correct?
what?
This will be on YouTube?
I am recording it right now. Yeah, I will put it on YouTube. Yeah.
Thank you.
So I have to make sure I draw good. Then if you're gonna put it in YouTube. So we know about sigma. Not freaking out. We expanded. We need to freak out if I, instead of 4, if I tell you guys go to 400, that would be a problem. So now we have to evaluate each package. The first one is 4 minus 3 times 0 squared. So 3 times 0. So in order to evaluate this, we apply the parenthesis first. We have multiplication. This is going to be 0. 4 minus 0 is 4. Then 4 squared will be 16. So the first one will be 16. What's the answer for the second one? What's this one?
Sorry, Professor, wouldn't it be 4 minus 3?
What is
Why?
very good.
What happened to the 3?
Okay, you're gonna be on the YouTube. So
oh, awesome. You're gonna be famous.
Good question. So I'm gonna break this. I'm gonna bring it here. So we had 4 minus 3 parentheses 0, then a square, correct? So there is no rush. We talking about minus, then here's a multiplication. So usually we don't put 3 multiplied by 0. If you don't see the multiplication, I mean this part is same as multiplication. So what is 3 times 0? So you gotta, before we go from left to right, we have to go follow the PEMDAS, correct? Parenthesis, parenthesis, exponent, multiplication. Good. So should I subtract 4 minus 3 first, or should I multiply 3 by 0?
3 by 0.
Yeah, 3 by 0 is 0. Then we have 4 minus 0 is 4. Now we're done with the parenthesis, then we have exponent here. 4 squared gives us 16. Good?
Yes.
Edit the video or?
No. Edit me out.
That was a good question. You need to ask. Please ask. And this is a very good exercise for the basic algebra. How do we apply the order of operation? So what is the second parenthesis equal to? Musa, you tell me.
3 times 1.
Very good.
3.
3 times 1 is 3. 4 minus 3.
1.
1. Then 1 squared is 1.
1.
Yeah.
Right?
Yes. 4 minus 3 times 2 squared. So 3 times 2 is 6. 4 minus 6 is negative 2. Negative 2 squared is
It's
Four.
4.
4. Negative 4.
Positive or negative?
Positive.
So we have parenthesis. Inside of the parenthesis, we have -2, and we have a square there, correct? This square tells us to multiply the base 2 times. So that means -2 times -2 gives us +4. So it's very important. This might be another question in your quiz. So let me have little Claude here. What is -3 squared?
You said -3 squared. Where
Yeah,
did
like
you write
this.
that?
I wrote it right there in the next to the sum.
Okay, up there.
9.
That's not- Is that +9 or -9?
Positive 9, sir.
Good. So if you're very good, but let me explain. If the question was -3 squared, then we have, that means -3 times -3 give us +9. But if you have a question like this, this exponent only belongs to the base 3. So negative is outside. We have 3 multiplied by 3. The answer is -9. So the answer is -9. If there is a parenthesis, it will be positive. If it's no parenthesis, that means the exponent only belongs to this part. Does that make sense?
Yeah.
Very good.
Thank you.
Very good, very good. So let's go back to the plan. So we got, this one is 4 plus, what is this equal to?
I got 25.
So before we apply the exponents, I'm gonna, you have 3 times 3 is 9. 4 minus 9 is 5. 5 squared is 25. Plus this last one, 3 times,
64. Oh, sorry.
okay, the 60, so we have 12. 4 minus 12 is -8. -8 squared is 64. Now we have add them up. So in your exam, they ask you to evaluate. So you need to add them up. You have 16 plus 4 is 20. 1 plus 64 is 65. 65 plus 25, 80, 90. 90 plus 20 is 110. I mean, you use calculator. The way I calculated, I saw 16 and 4. They add them up, correct, good. Then, so you use calculator to add them up. Let's have one more question like this. Sigma, it doesn't need to be I all the time. It can be any letter. I can say X starts from 1, and at 4, we have mu minus X squared, where mu equal to 4. So say evaluate this one, mu equal to 4. So we know everything on this question. So is it mu equal to 4? So I can substitute. I can just substitute mu there to have, for example, we're going to have sigma 4 minus x squared, x equal to 1, and at 4, this is equal to 4 minus 1 squared plus 4 minus 2 squared plus 4 minus 3 squared plus 4 minus 4 squared. Correct? That's the first step. We just expand all the sigma notation. 4 minus 1 is 3. We have 3 squared. 4 minus 2 is 2 squared. 4 minus 3 is 1 squared and 0 squared. 3 squared is 9. 4, 1 plus 0, it gives us 14. All right. Any question here?
What was, I'm sorry, Professor, what was the answer for the previous one? I missed
I
that.
think you got 110.
Okay, got it. Thank you.
Oh, I did it in my head. Probably I'm wrong, but if you add them up, you should be on it.
I hope not, because I use a calculator and that's what I got, so.
Oh, good. That's the good news. I shouldn't give up. So it's good. So, but in exam, I'm not looking for this one. Don't type this. This should be in your just in your paper. You calculate. I'm looking for this one. So evaluate. So you get the answer will be this one. But in your homework, they might ask you write it, expand it. You write this and then this one. There are 2 options on your homework. But in exam, I'm just looking for one answer. Another question, so we talked about exponent. We said like a 3 squared equal to 9 and or a to power of n. This means a multiplied by a multiplied by a. We multiply it n times, correct? That's the definition of exponent. For example, 5 to power of 3. That means 5 multiplied by 5 multiplied by 5. In your calculator, you will get 125. If I ask you guys what is a to power of 4, that means a multiplied by a multiplied by a. Any question here? That's the property of exponent. But the question is, if I ask you guys what is 5 or 5 to power of negative 2, how many times should I multiply 5 by itself?
Twice.
So if I multiply twice, I get 25. What's the difference between 5 squared and 5 to power of 2? I mean, these two going to be same answer? No, definitely there are 2 different questions. This property that we have a to power of n, you multiply the base. This is the base. You multiply the base n times only when n is greater than 0 and is integer. That means 1, 2, 3, 4. So when we have a negative, we learn another property of negative exponent, which is a to power of negative n. This is same as 1 over a to power of positive n. So we need to make it to positive exponents. So the first step, I'm going to make this one to positive 2. Now when we have positive exponent, I can say 1 over 25. So the answer is 1 over 25. So this is super important. Anytime you see negative exponent, we make a reciprocal to get a positive exponent. But in your exam, because this is not the algebra course, you're having a calculator. And I don't think they ask you to leave it in exact form. So this is the exact form. But when they said rounded to a few decimal points, so you plug this one in the calculator. How do you put in the calculator? Make sure the exponent is on the parenthesis. Another example, 25 to power of 1/3 multiplied by 5 to power of 1/2. Or not, don't make it complicated. So 25 to power 1/3. So what do we do here? The property that we love, a to power n equal to a multiplied by a multiplied by a, we multiply it n times, but you use this property when n is positive, first of all. Also, n should be integer. That means it can be 1, 2, 3, 4. Only when it's integer, we can use this rule. 1/3 is not an integer. So we cannot multiply the 25 somehow by 1. We cannot multiply it 1/3 of times. So what do we do? What should we do here?
We convert it into a decimal.
How do you make it to decimal?
I just know it at the top of my head as 0.333 with the infinity bar, but I don't really know how to do it.
Very good. So we do use the calculator. I mean, there is not for this particular question, we can do it by hand, but anytime you see a not integer on the exponent, we're gonna use a calculator. This is a calculator. Okay. How do you put in the calculator is important, guys. This is gonna be 25 exponent 1 divided by 3. I know 1/3 is 0.333. We don't want to do this. We don't want to put 0.333. We're gonna just let the calculator does it for us. So this has to be in parentheses. What do we get if somebody can you tell me what was the answer is?
I got 9. Oh gosh, 2.924.
It should be. I mean, if I multiply 2.924 3 times by itself, no. Okay, we don't want to go back. So this is the answer. Use a calculator. What about but in algebra, if there's a question like 32 to power of 1/5, again, the exponent is you guys don't like it. We have to use a calculator. For this course, we use a calculator, and we make sure we type it correctly. But in algebra, we say 32 is 2 to power of 5. Then 2 to power of 5 to power 1/5. The 5 they can cancel. The answer is 2. That's the exact 2. But don't worry about this. I'm assuming that you guys already know this. I don't want to question you guys. But for this course, I would like to you guys make sure you type it in the calculator correctly. Just have one more question on what you're gonna see on the exam. 1/2 to power of 2/3 plus 3/8 to power of 1/5. So pretty ugly question. I mean, in algebra, this is gonna be pain to find the exact answer, exact value. I'm not going to ask you to find if exact value, that means no calculator. But you guys are going to use a calculator. Can I tell you what is the answer with 5 decimal value? What'd you get?
I got 1.45.
Exactly 1.45?
No, oh, sorry. 1.45183644.
Not that much. I was happy with 4. So when they said round it to 4 decimal, so make sure you round the last digit. In this case, 3 is less than 5. I will keep the 8s. We don't want to lose points. If instead of 3 was 5 or 7 or more than 5 or equal to 5, we have to make the 8 to 9.
Professor, do you want it in decimal points, or is it okay if we have it in like square roots?
No. Does the square root will be challenging? I mean, the question asked you guys rounded to a few decimal places. That means you need to use a calculator.
No.
So you need to make sure how to enter it.
Okay, sure.
I will get the answer here first, then I will add this one, then I will add them. All right. What is 5 to power 0.23?
One 1.44. 8. 1.448.
So the if you have a question like 5 to power of 4, if the exponent is integer, you don't need to use a calculator. That means you got to multiply the base 5 times. Good. 2625. But when we have a fraction or decimal, you need to look into the calculator. You need to have a calculator. Is that correct? 1.448? Musa, what'd you get? You can sing, I don't hear you.
I'm still typing it.
Wow.
I'm slow. I'm very slow. I'm sorry.
No, the same, 5 point to the 4 digits. 5.
I'm still on the first question.
Oh, here, the top one. Yeah, top
Yeah.
one is like I say, yeah. Good. That means you are careful about the parentheses. You don't need to type everything, and you don't put in the phone. Make sure you have a graphing calculator. Oh, well, you have. Oh, anyway. All right, guys. So when you see an exponent is not integer, just make sure you use a parenthesis and then use a calculator. All right, let's see. Let's go back to a statistic. So that's the big picture. Are you guys ready for a statistic? I think so.
I think so.
Yeah.
That other stuff looked too complicated.
And it's complicated, but you have a fancy calculator. You just type it in.
I have to figure out how to use my fancy calculator.
That's Google it. Yeah. You have. If I put 14 questions for like 1 hour, 90 minutes, and so there are homework questions. Most of the questions are I copied exactly from the homework. So you talk about interval. So you need to know, you have to review the interval that we talked about. The interval notation, like we have x less than equal to 3, more than -5. This is same as parenthesis -5, comma, bracket 3, correct? You remember we talked about the inequality notation and interval notation? We did the homework on this. You guys did the homework on this. So there are a couple of questions like this. And nothing surprising. All right. So the statistic part. The point of this statistic course is, or statistic is, we would like to get the idea about population. But because population is huge, we cannot apply, or we cannot get all the information from a population. We pick sample, and getting a sampling, and apply the statistic on sample, this create a statistic. We are able to study the sample, and from this sample, we apply a statistical inference to get an idea about population. This part, I think we are equal, but I know you guys know too about sampling. I mean, I say it because the finding the average, 5-number summary, graphing it, the standard deviation, you know it because the computer give it to us, correct? We pick a sample, we put that data inside of the computer, and computer give us all the information. When you see X bar equal to 5.3, for example, if you're talking about the height, that means the average height of our sample was 5.3. If you see a minimum, maximum, so there's nothing into it. I mean, the minimum value of the height was like 2.8, the maximum was 7.4, for example. All of them make sense. That's why we are equal. We know exactly. So we can study a statistic. We can study the sample by the computer. Good. But now we are learning different type of a statistic, inference statistic, to get some idea about the population. In order to get idea about population, so we will deal with this sample. For example, the sample average height is 5.3. If you come up with the conclusion that this average height of population is 5.4, correct? If you come up with this, definitely this is not exact. Agree? Exact mean if you find everybody's and find the height of everybody, ask them. This is not exact. So when you're talking about population, when we say something about population, you need to say how confident you are, how much sure that you mean, what is the confidence that you guys tell me the average height of your that population is 5.4. So there is another variable come that said, oh, this is like the confidence interval, or I'm 95% sure that the average height of population is 5.4. All right. So definitely, not definitely, but it's not 100%. I agree. Good. So that's what we're going to learn today. Rosia, does that make sense?
I think I need to see examples for it to probably make
Yeah,
some sense.
because,
So I'm just like, it's too many words and I'm just trying to put them all together.
but that's the pictures going on. We are studying the sample, and then from the sample we like to make a conclusion about the population. When we come up with some number for the population, we need to say how sure we are. Are we 95%? Is it 100%? So we have to come up with some type of interval and the confidence interval. So let's review what we learned. Say about the inference. So this is a review from 3.1. A statistical inference is drawing conclusion about the population based on a sample. Good. We use a sample statistic to estimate the population parameter. So X bar is for us is for our sample, and mu will be the parameter for the population. That's how we differentiate them. We have S for a standard deviation for the sample. We have sigma for population. And to assess the uncertainty of a statistic, we need to know how much it varies from sample to sample. To create a sampling distribution, take many samples of the sample size from the population and compute the statistic for each. So if, for example, we want to study, we're going to find out the average height of the population, we cannot come up with one sample. We cannot make a decision for the population. So they're saying we need to take a lot of sample, and the sample size that we take, we don't want to be biased sample. It has to be random. And if you take 500 people, if there are 500 people in each sample, so we need to be, our sample should be 500. The standard error is the standard deviation of a statistic. Okay. All right, let's have one homework question. I think the first homework question that you're going to see is this one. The US Census indicated that 35% of US residents are less than 25 years old. So that's the population. So this picture shows possible sampling distribution for the proportion of sample less than 25 years old. For a sample of n equal to 20, n equal to 100, and n equal to 500. So that means if this is our population, somebody take a sample of 10, not only one, probably takes thousands of sample of 10 people, and then got the average, study that one. Another person got the sample of 100 people. Each sample was 100 people in it. All right. Another one is 500 people. Cool. Another question is, the question is here. Which distribution goes with which sample size? N equal to 20. Do you think the graph going to be graph of A, which is this one? Graph of B is this one, graph of C. Which one is N equal to 20?
Is it A?
Pretty good. Because you can see, I mean, they're far away, right?
Yeah.
Because 10 people doesn't give. So this is A, very good. What will N equal to 100?
That would be B.
Very good. And N equal to 500 will be C. So we pick 500 in our sample, which is more than 10 and 20 and 100. So definitely, whatever statistic we get is more related to population. They're close to each other. So when you pick 500 in your one sample, so this 500 is going to be around here. And you take another 500. So whatever statistic, if you want to find the average height, for example, or the age, because of number of the sample, it will be related to each other, so it will be close to each other. Part B. Can you see this? So for first one, if we use a proportion rho hat based on the sample size of n equal 20 to estimate the population parameter p equal 0.35, would it be very surprising to get the estimate that is off by 10%? And we already know that the population is 35%, correct? We already know it here. But with sample size of 20, definitely 10% off, we are not going to be surprised. Would it be surprising to get estimate that is off by more than 10%? No, because Enika, there's going to be no, because with 10 people in our sample, we're going to be very off. What about sample size of hundreds? You guys hear me?
How would we calculate it? I mean,
Very good. How do we, but we are comparing three samples. Definitely don't make it that complicated. We're just comparing it. So how would you, the sample size of 100, I would be surprised. We're going to say, because 100, we pick enough sample. So 10% is very off. More than 0.10 will be very off. So I would be so surprised, yes. Surprised for n equal 500, yes, I will be surprised. We shouldn't be off by 10%. Correct?
okay.
I know you like to calculate to find it, but no, we are just comparing the ABC. Let's have another one. Now the error is 0.05. So the error become less, correct? So here for the 20 people, would you be surprised? No. For 100, I would say no. For 500, I would be surprised.
So is it always safe to go with the sample size over 500?
Yeah, more sample, yeah. But in this case, between 20, 100, and 500, this exercise was showing you that we're gonna have more than 10% off if our sample is very small, less than 20 people. But when you get to 100, then we might have a little more error. Okay, 0.05.
That makes
500.
sense.
Yeah. All right. Any question here? So section 3.2, we're dealing with confidence interval. What does it mean? That means when you apply discrete statistic to the sample, then a statistical inference to draw a conclusion about the population, your answer not going to be 100% sure. You're going to say, with this, it could be 90% confidence interval or 98% confidence interval, your parameters are correct. Good? So that's what we're going to find out. So the outline of this section is interval estimate based on margin of error, confidence interval, 95% confidence interval using the standard error, understanding confidence interval, common misinterpretation. So basically, we are going to deal with confidence interval. You okay, Musa?
Something else. I'm thinking about. Sorry.
Business? Share with us if it's So I very like that you guys have those all the terminology or the keywords. You need to have it on. You should have a good note for yourself. Otherwise, it would be super complicated to memorize them. So 3.2, talking about confidence interval. Let's have one example here. So a report from Gallup poll in 2011 based on a random sample of N equal to, so around 100,000 people. There it says 45% of American adults reported getting their health insurance from an employer. So that's a big statement. So they're talking about the entire population, 45%. Now for you is the question, I mean, did they actually knock everybody's door and then they said, they'd asked that question? But that's not possible. They deal with the sample. They pick the sample up. So the sample is like around 150,000 people. Not only one sample of 150,000 people. So now the question is, how accurate is 45%? Is that for sure 45%, or is it 45.1% or 45.3%? All right, so we need to ask them. So let's keep this question here. Let's move to interval estimate. An interval estimate gives a range of reasonable values for a population parameter. So in the previous question, they said 45%, correct? So the parameter, so here we're gonna have an interval estimate gives a range of reasonable value for the population parameter. Plausible values for population parameter. Margin of error. One common form for an interval estimate is a statistic plus minus margin of error, where the margin of error reflects the reasonable of sample statistic as a point estimate for parameter. So let's go back to that question. Now we have interval estimates. It's a 45%. So later in the report, so this is important, later in the report, they said the maximum margin of sampling error is plus minus 1%. So 45% plus and minus 1%. So if this is, for example, is 45%, they said plus 1% and minus 1%. So this is an interval that the population, whatever the, so the population will be between 44% and 46%. The real population, so what was the question? The maximum was here. The percentage of American adults getting their health insurance from an employee is probably between 44% and 46%. So we cannot come up with one number. We came up with the interval. It might be 44.3%. So from 44 to 46%. So how did we get this interval? By getting this information. How do we come up with this information? How do we come up with error? How do we calculate the error? That's what we're going to learn. Let's have one example. So a 2011 random sample of n equal to 755 cell phone users age 18 plus found that the average number of text messages. So 41.5 messages with the margin of error of 12.2. So this comes with, we're going to learn how do we calculate the margin of error. But right now we said they give it to us 12.2. The question is, give an interval estimate for the average number of text messages sent or received per day for US adult cell phone.
So would we just take that 12.2, subtract it from the 41.5 and add it to the 41.5, and that's how we get the interval?
Very good. Very good. So the formula is, so 41.5, we're going to add the margin of error, and we're going to have 41.5 subtract 12.2. So this gives us interval. I'm not using bracket, because bracket, that means I'm including that last point. It's going to be open. Good. So the answer will be 41.5. So the answer is going to be 29.3 to 53.7.
Good.
Correct. Does that make sense now? So we are dealing with population and we cannot just come up with the exact number for population. We come up with the interval, and that interval, if our sampling is good enough, not 10 or 20, 755, and not only one 755, we have a lot of 755. So that's how we calculate the interval. Now we're going to deal how confident we are that's going to lie in that interval. Is that 95%, 98%? Let's have another, okay. Confidence interval. A confidence interval for a parameter is an interval computed from a sample data by method that will capture the parameter for a specific proportion for all samples. I mean, just memorizing it, not good. This should make sense to you. What is confidence interval? Catherine?
Yes, I'm here.
Any question, Catherine?
I'm trying to understand the meaning of it.
Very good. Yeah, we need to understand the meaning. We don't want to memorize the definition. This so confidence interval for a parameter. Parameter is something related to a population, like mu or standard deviation, or so is an interval. So the confidence interval, the success rate is known that as confidence interval. A 95% confidence interval will contain the true parameter for 95% of all samples. %. In this, we deal with 95% in this course. So if the sampling distribution is relatively symmetric and bell-shaped, 95% confidence interval can be estimated by a statistic. That means whatever we apply to the sample, like standard deviation, X bar, rho hat, plus minus 2 times the standard error. This 2 times the standard error is same as margin of error, but previously on the last question, we just add and subtract the error, but here we have 2 times standard error. They're different. Yes, Mariana?
Nope, just taking the notes.
Okay, let's do this question together. A survey of 1,500. The standard error for this statistic is 0.01. What is a 95% confidence interval for the true proportion of all Americans that consider the economic? Let's see.
Ooh, I got it wrong.
So what you did,
Oh,
you just
86.
subtract 1. I didn't give you margin error. I give you a standard error. Standard error, you need to use this formula.
Oh, okay.
You have to multiply by 2 for a standard error.
I see where I'm at.
Very good. Santai? Asante, correct?
Asante, sir.
Asante. Thanks for
No worries.
participating. The first
It's all
time
good. Thanks for trying, though.
that's good. Is the first time you're joining us, or you've been here before?
Yeah, it is my first time. I've been trying to find the class for a minute now, but I'm glad I'm here.
Did you take the first exam?
Yeah, I took. I think I've taken everything up to this point. I've been kind of like self-teaching, and it hasn't been going well. So I'm glad I got your assistance now.
Very nice. Yeah, their course, you have so many resources on Canvas. You guys loaded with a lot of materials, so it would be good to just, I'm the little extra, but I think there's enough on Canvas to just learn by yourself. Very good.
Yeah, that's what I've been doing.
Excellent. That's fine. As long as you do good, I'm okay. I don't see your name here somewhere. Anyway, so any question here? No question. Let's summarize. This is some important thing that we need to make sure we don't misinterpret it. First one, a 95% confidence interval contains 95% of the data in the population. Not correct. Good, should click this. This is not good. Second one, I am 95% sure that the mean of sample will fall with the 95% confidence interval for the mean. When we're using 95% interval, we're not talking about the sample, we're dealing with the population. The last one, the probability that the population parameter is in this particular 95% confidence interval is 0.95. That's not correct. We're not talking about probability. This is sample. So those are, we have to make sure we don't do a mistake. So let's wrap it up and then we do activities together. So that's what we learn about confidence interval. We have population, we take sample, and we don't take a sample of n equal to 20 or 100. We make sure as much as possible, correct, 500, 700, 1,000. So we take a sample with the same size, random, I mean, we have to make sure the sampling is correct. Then we graph all of them here. And last week we learned that when you graph them, it will look like a bell shape, symmetric. And this mean here, for example, will be similar to the population mean. There is an error, a statistic plus merged error for 95% confidence. The merged error, this ME, equal to 2 times standard error, or a standard deviation of sampling distribution. This is SE. So each dot here each point, this, for example, represent to one of the sample. This sample, this one, for example. All right. So each dot is a sample, and each sample has 500 people in it. Good. For example, this sample n equal to 500 and x bar equal to 4.8. If this is an x bar graph, for example, going to be here. Then I do the same thing for another sample. And we plot it. And after graphing them, you will get a bell shape. Good. I don't know why it become like this. Let's do some activities. First question. The higher the standard deviation of the sampling distribution, the higher or lower margin of error. Is it A or B? The standard deviation of
I think it's B.
the higher of a standard deviation. Standard deviation, we're dealing with the sampling. Good.
I think it's A. I
We're
think we
gonna have higher margin of error. We're gonna have more error if the standard deviation is sampling distribution. The higher of a standard deviation. That means our sample gonna be like this. This is gonna be one standard deviation, which is gonna be standard error for the population. So it will be higher margin error. This is a lot of error. So, I mean, one sentence, but look at the standard deviation and sampling distribution. So when you see a word like this, that means there is a population, we took a sample, and we are dealing with the sample. And so in your mind, you need to navigate through the question. Let's have another one. Why they're big? The higher of a standard error of a statistic, the uncertainty surrounding the statistic. Is it higher or lower? Standard error is one keyword. The statistics, that means we are dealing with the sample, correct? Parameter will be the population statistic. The higher or lower uncertainty surrounding the statistic. Don't lose your confidence interval, say it, that's fine. I lost my confidence because I am not sure how to pronounce asantry.
I think it's lower. I could be wrong.
You like B, I'm gonna go with A, asantry. It's gonna be higher, uncertainly, because we got, again, the standard error is the higher of a standard error. That means our sampling, again, is messed up. You're gonna have data. This is sample. Standard error is high. The standard error, same as the standard deviation on the sampling. Should I go back?
Yeah, for a bit.
Pictured in mind.
How the standard error statistic certain. Okay, that makes sense. The higher the uncertainty.
Let me see if I can get. This is a standard error, for example. Let's say this.
I see. Okay. Okay, that makes sense.
So if you go back to the higher of a standard error of a statistic, the higher uncertainty surrounding the statistic. Does that make sense with this picture?
Yeah, it kind of pieces together. It helps.
Okay. Standard error. So now we have a standard error. A survey of 1,000.
Is it B?
Catherine? Yes, it will be B. So we're going to use the formula, correct? We cannot just look at it and say, the formula is a statistic plus minus 2 standard error. Standard error standard deviation of sampling. If it's less, that means we're doing good. If it's more, that means something's wrong. So this is 0.01. So this will be the interval, which is this guy. Unbelievable, right? They are huge. Let's see who can answer this. Musa, confidence.
No.
You are fully confident.
No.
Show me your confidence.
Wrong person.
Which of the following is an appropriate interpretation of for 95% confidence? So again, you guys need to study a couple hours a day, or at least few hours a week, to have all those keywords and new topics to write it in the page of notes to refer to it. So now we are dealing with 95% confidence, correct? This is what we learned today. So you should have one-page note on this. Should I say we are 95% sure the interval contains the parameter? B, there is 95% chance the interval contains the parameter. Both A and B, neither A or B. Rocio.
Let's see.
Good. Very good confidence. Let's see. Just gonna read it. Just gonna read it.
I'm gonna say A, since it's a 95% confidence interval.
Very nice. A is correct. A is correct. B, they're talking about the chance, correct? We're talking about probability. We learned that this is not a probability. You're 95% sure. There's 95% chance to interval contain. So there is no probability for sure, 95%. So A is correct. I think the answer is here. Let's read this. So that's the answer. We cannot make probabilities. Probability. All right, this a question for Musa. I cannot go easier than this.
No, you like picking on me. You like picking on me.
Oh, I just want to give you
I'm
confidence.
going to report it to Skyline.
I know. Become like a private teacher for you. Is correct or incorrect? I have confidence if I pick on Rocio gonna answer this. Okay, I built my confidence. Stephen, wow, I have an LG4. Did you rename your? I said nobody can rename. Steve.
Oh yeah, I changed it because my other class, my teacher required me to put it there.
LG4, is that the?
Yeah.
Is that
It's group 4.
I see.
Yeah, because we're in a group for that class.
All right, good to know this. What is that, A or B?
It will be A.
A?
A.
Who said no? I think it's A is not correct. So again, the interpretation, so a 98% confidence interval for a mean pulse rate is 65 to 70.
Average.
The interpretation. I am 98% sure that all students will have pause rates between. No, is incorrect. This is talking about the mean, not individual.
But I mean, the average person has a heart rate of 65 to 71.
Average, but they didn't say average, they said all students. So I'm sure that all the students will have a pause between this and that. The average of them it will be between 65 and 71. Not, we're talking about the mean. What about this one? Same question. I mean, no, we're a little bit different. So I'm 98% sure that the mean pause rate for this sample of a student will fall between 65 and 71. Is that true?
That sounds more like correct.
Who said that? Investigate that. Let's see, it was you? No, Maria.
No, it's me. It's Manpreet.
Yep. Oh.
I just feel like everything's been incorrect and wrong. So there has to be one answer that's right.
We have to play it safe.
Kathy, what do you say?
And so we have to play it safe.
Yeah.
Because in this question, it's not saying all students, it's only saying sample of students.
Mhm.
So is that correct or not correct?
I'm going to have to agree it's correct.
Correct. And Manpreet, you said correct.
Yes, I say correct.
And anybody else think is incorrect? Musa saying,
I say it's correct.
oh my God.
Yeah.
It was breaking.
I mean, you can't. No, 65 to 71%.
You're not doing super lotto here. Just come on, guys. Okay, let's see what's wrong. The answer is incorrect. Incorrect again. But the good thing is you're learning, and I will bring a question like this in exam that you know it now. Why is incorrect? They said, I am 98% sure that the mean pause rate for this sample, we use this 98% confidence only to the population. We don't deal with the sample. I mean, sample, we can calculate it. For sure, we can get the answer for sample. So it's incorrect because it's dealing with the sample. Good? Let's have another one. So it's incorrect. Now you guys don't trust me at all. Just what about this one? Now you guys don't talk. Is that I am 98% sure that the mean pause rate for the population of all the students will fall between 65 and 71. Is that correct or incorrect?
That has to be.
That has to be correct.
That's correct. Correct.
Well,
It has to be correct.
we go correct because we had incorrect. This going to be correct. There are 4 more questions. So is that incorrect or correct?
Well, because you said population.
Yes.
Yeah, exactly.
So yeah, we talk about the mean. This is the mean. Population, 98% confidence is correct.
Finally.
I have no confidence, to be honest.
I have negative 98% confidence that I'm understanding them.
Right with you.
This is a brand new, guys. I mean, that's acceptable. You do the homework. Again, you just like it for this semester and then dislike it. Just do well on the exams. So let's do this one, something little algebra in it. So a 95% confidence interval, you're gonna picture the entire world population, goes from 18 to 22.
Is that
What
B?
is the margin of error?
Oh.
What?
B.
Are you
2.
sure?
Okay, you're making my confidence level go down, but yes, I am going to say I'm gonna stick with 2.
So we have a margin of errors. We have page of notes, correct? You write the notes. You don't draw a picture. You just write all this. And there's a formula. They said 95%. It will be, so we have 18 to 22. This is gonna be like, let's say mu minus margin of error. This is mu plus margin of error, correct? That's how you solved it?
Yeah.
Yeah?
I mean, I just kind of,
Kind
yeah,
of
sure.
guessed it?
No, that is the formula, correct? Yeah.
But how did you do it?
I don't know. It's just 2 popped out to me. I just figured there's a number in between
There's so many
18 and
incorrect popped up.
22. Yeah, it's just 2 popped out at me.
But we don't want to do that. We're gonna go follow by the rules.
Okay.
We have like a parameter minus margin of error give us the lower bound, and the plus margin of error give us 22. So how do we solve it? We can either use 2 equations, 2 unknown. We can say mu minus me equal to 18 and mu plus me equal to 22, correct? 2 equations, 2 unknown. If I add them, this gonna give me 2 mu. This 2 cancel. I will get 40 divided by 2, mu equal to 20. So mu equal to 20, then 20 minus 2 gives me 18, 20 plus 2 gives me 22. So 2 is correct.
Oh, jeez.
I thought you did all of them in your head. So, well,
I did, exactly. That's how I knew it was B right off the bat. I think I'm better at algebra than I am in statistics, so.
Let's have another question for you then. The next question is this guy. If you solve, oh my God, this happened because I rotate my iPad when it was downloading. What about this one? A 95% confidence interval goes from 90 to 110. The standard error is this.
I think I'm gonna go with B again, but
Like
somebody else can answer.
Anybody else? So we have formula. We don't want to just waste our memory. We have page of notes. The interval is 90 to 110. The formula for confidence interval, standard error, correct? We have confidence interval was plus minus 2 standard error.
Standard error. Oops.
Correct. So 90 gonna be, for example, mu minus 2 SE, comma, mu plus 2 SE. Good. So mu minus 2 SE will be 90, mu plus 2 SE will be 110. If you do algebra, you're gonna have 2 equations, 2 unknown, mu minus 2. I'm gonna call this one x to be easier for you guys. 2x equal to 90, mu plus 2x equal to 110. I add the 2 equations, the x will go, I get 2 mu equal to 200, then mu equal to 100. So I find the parameter, I just called it mu. But now I plug it back, for example, to this equation to find x. So we had mu minus 2x equal to 90. So 100 minus 2x equal to 90. I subtract 100. I get negative 2x equal to negative 10, x equal to 5. So s equal to 5. I know a little algebra here. I will go about the two equations, two unknown on Wednesday.